Observed value and calculated values for the SRP, standard reduction potential, standard electrode potentials of elements titanium to zinc. The first reactivity series are depicted. Explain the following thing. That is here. The general trend towards the less electronegative values across the series. Why? Why it goes less electronegative? And the unique behavior of copper and the more electronegative values of magnesium and zinc. So the electronegative values goes on towards positive side. That is less electronegative value or positive side. And there is a difference in the case of manganese and in the case of zinc and in the case of copper. These two are not according to the trend. These are all different from the trend. That is why they are asking the question. The general trend towards the electronegative values across the series. So what is the general trend? That is what we have to understand. First of all, what is the general trend? Answer for first question. That is less electronegative, less electronegative. And the standard reduction potential value or the standard electrode potential value depends upon, it is directly proportional to the enthalpy of hydration. Enthalpy of hydration plus ionization 1 and ionization 2, IE2, right? So the standard reduction potential values directly depends upon these three things. That is the enthalpy of hydration and the ionization potential 1 and the ionization potential 2. From the titanium to zinc, we are seeing this from the titanium to zinc, titanium to zinc. From the titanium to zinc, the standard reduction potential value, the ionization potential value increases, right? So that the standard reduction potential value increases. That is less negative. That is towards a positive, right? In the case of copper, second point. In the case of copper, copper is, we know that 3d10 4s1. So it is easy to remove this one electron. So IE1, it is easy to remove one electron, but it is not easy to remove the 3d10 electron plus IE2. This value will be higher. That is the IE2 value will be higher. The ionization enthalpy value, this will be higher. This will be higher, right? So put together both the values, that is ionization enthalpy values will be much higher, will be much higher than the hydration enthalpy, than the hydration enthalpy, than the hydration enthalpy value. So these two values for copper will be much higher, will be more than the hydration enthalpy value, so that SRP is positive. Got it? The ionization enthalpy values are much higher than the hydration enthalpy values, so that the SRP value for copper, that is the reduction potential value or the electrode potential value for copper, is positive. Got it? And the third question, more negative values for M1 and ZL. More negative values in the sense it decreases actually, right? So towards the trend from titanium to zinc it increases, but in between manganese and zinc it decreases suddenly. What is the reason? So obviously manganese, zinc or chromium or copper. These four things, when comes into the picture, we have to think about the stability itself, right? So manganese and zinc, obviously we can say they are in D5 configuration, right? They are in D5 configuration. So what happens here? In the case of manganese, M1, that is D5 4s2, 3d5 4s2. So first ionization enthalpy, removal of one electron, IE1, plus second ionization enthalpy, removal of second electrons. So this will be very less in the case of manganese because it tends to attain the 3d5 configuration. 3d5 configuration, right? This will be very less. This will be very less. Same in the case of zinc too. Zinc means it is 3d10 4s2, right? The first ionization enthalpy is for removal of one electron, plus the second ionization enthalpy is for removal of the second electron, right? So this will be very less. This will be very less because it tends to attain the 3d10 configuration. So in these two cases, the two values will be very less than the hydration enthalpy, so that the value is more negative. The value is more negative. The value is more because the ionization enthalpies, that is IE1 and IE2 of both manganese and zinc, is less than the hydration enthalpy, is very less than the hydration enthalpy, so that they tend to attain the stable gas configuration. This is half filled configuration, this is completely filled configuration, and that is why this is more negative. But in the case of copper, the second ionization enthalpy will be much higher, and so that the put together the ionization 1 and ionization 2 enthalpies will be much higher than the hydration enthalpy, so that the value of copper, or the SRP of copper, is positive in nature, more positive.